Well, good afternoon, Encompass students. We are here today to discuss the AMANA Dryer. Um, an AMANA Dryer is very similar to a Whirlpool dryer, since Whirlpool makes AMANA dryers. Um, there's many of the brands that are familiar to us that are made by the manufacturer Whirlpool. There's one of them is a lot of the brands from, Sears. They make the Sears brand dryer. They make the Amana. They make the Maytag. They were Amana was bought out by Whirlpool, and Whirlpool bought out Maytag, and Whirlpool bought out several of the other smaller manufacturers and made themselves one of the big powers to be. So let's just go ahead and get started. If you have any questions, go ahead and put your question or your comment down below in the space provided. Go ahead and just let me know. I am going to revert back and forth to a screen where I actually can't see the comments that you leave to begin with. And then we're going to come back in a little while, and we're going to sit back and we're going to discuss any of the issues that we have. So the first part of the class is going to be basic electricities. If you can't read a wiring diagram, or you can't read a meter, you need to go back and read and brush up on all of those. There is a class that will be taught 101 basic schematic diagrams, and then we're going to have a meter reading class probably in September. So we're going to go ahead and get started. If you have any questions, like I said, please go ahead and put them down into the comment section. Okay, so going to meter basics. Meters are designed to measure three properties found in a working circuit: resistance, voltage, and current flow. Okay, that's why you know your meter as a multimeter, because it checks many other things. Do all meters check all three properties? No, they don't. Okay. They can perform multiple functions and measure different kinds of voltage or currents. They use either AC or DC, and that most of them will check all of those. Okay. They will check an AC and a DC, both the voltage and the resistance. Current flow is a little different. What current flow is measured as. Okay, we're going to start with resistance. That's the opposition to the current flow at a component level that has been measured in units called ohms. It's a capital OHM and it's apostrophe S. Okay, all electrical components or devices have a resistance value. The symbol for ohms, of course, is the upside down horseshoe. So, as an example, I've listed many of the examples right there. An inductor, a circuit board that you go and probably deal with every day. Power supplies, again, is another example. Resistors and diodes. If I'm checking a diode, I require a 9-volt battery because that's how I check my diode. All right, so we're going to keep on going. Let's talk about voltage. Voltage is the electrical potential or potential difference between 2 points, measured in units called voltage or volts. Okay, the symbol for voltage, of course, is the capital V. This is potential can be either DC voltage, okay, which is direct current, or AC, which is alternating current, okay. Examples of DC voltage: your car battery operates on DC voltage, okay. You can, many of the voltage in, several of the DC circuits that are in refrigerators, there's a board. Some of the refrigerator boards actually can convert AC to DC in the board itself, and that would be an example of just a voltage that I would need to know if it's either AC or DC. Okay, my AC voltage is, can be 120 volts, can be 240 volts, but it's the line that powers your home in circuits, and the voltage coming into your house is much higher than 110 or 240. Okay, the line voltage coming into your house is much higher than that. Excuse me. So we're going to keep on moving on. So here we go, and we're going to talk about current. Okay, current is the flow of electrons through a conductor at a certain rate, and it's based on the voltage source provided and the resistance to that current flow of the circuit. So we measure current, okay, in amperes or amps. The symbol for current is A. Okay, so many of your meters will check it all, but some of the other meters only are for AC, DC, and resistance. You have to have the meter that also will check amps. All right. So an example of this is like a light bulb in your home. When you turn the light switch on to the on position, you complete the current path from the source, the 120 volts fuse box, through the switch and to the light bulb, and then back to the fuse box, which is the ground, and it's an AC current. Okay, it could be a DC current, like my trailer has DC current running through it. Just a moment. Excuse me. I apologize about that. Goodness, I thought that I had gotten rid of all of my allergies, but pecans are now in season, and that's driving my schnauzer crazy. So, which is my nose. So the current uses AC, but it could use DC current, like I was saying. My trailer uses DC current for light bulbs. So you got to know if I'm running AC or DC. So as just a quick source, what do you think? How do you think I would know an AC circuit from a DC circuit? Does anybody have any input? Sorry, I almost sneezed again. Come on, guys. Think about it. How would I know if I've got an AC or a DC? Okay. If you think about a microwave and you go you go and you start checking things in a microwave, how do I know if they're AC or if they're DC? Same thing in a refrigerator. 9 times out of 10, if I'm checking something on my refrigerator and it has a larger wire, that would tell me that I'm probably got my voltage is 120. Okay, if I'm running smaller wires, that is probably a DC voltage, and that's not just the total rule of thumb. Okay, but that's what I'm going to look And how do I get that information? I am going to go and look at the wiring schematic itself, or the wiring diagram, however you want to call it. Okay, so that's what I need to know. But whenever I start checking something, because what will happen is if I put my meter on DC voltage and I put it on I put my lines to it, and I'm measuring AC voltage instead of measuring DC voltage, because that's what I thought it was. I will blow it up I will blow my meter up. Usually there's a fuse in there. I can replace the fuse and it will work again, but you never know. Okay. So what's my meter's role? If I look at this meter that I see right here, okay, I know that I am checking ohms because of where it is on my scale. As identified above, it is the meters. It is critical to remove the operating power source from the unit before you diagnose it. Most common method is to unplug the unit from the wall or turn it off at the box, because you don't want any power going to the appliance unless I'm checking for actually AC voltage. Okay. So if I'm measuring resistance, once the power is removed, you can use the meter's ohms function and measure the internal battery. So I'll use the internal battery to check the ohms. Okay. So if you look at this one right here, this is the ohms that is shown in this meter. Once again, this is not an expensive meter. Okay. How am I going to go if I'm trying to check line voltage, okay, and I'm trying to check it at the plug itself? If I have any discrepancy, I'll take the back cover off. Whenever I take that back cover off, it exposes this terminal block. Okay. From this point on, I can look at this terminal block and I will know what is 120, what is 240, and then I have a neutral and a ground. Okay. So if you look at it, the L1 is your hot leg. Your neutral is the white wire. Then I have an L2 that is 120 volts. And then I have, if the appliance was built since 1979, it has an earth ground. Okay. So my 3-pronged plug has now turned into a 4-pronged plug. So if I am going to do that, I need to know that I have an additional earth ground. So what does an earth ground actually do? Well, just like the name says, an earth ground grounds the appliance, okay, physically and electrically to the earth, okay? It is via a conductive material. These are one of 3 ways that they achieve it. It's a rod that is driven into the ground, okay? It is either copper, aluminum, or an aluminum alloy. What will happen is this rod is being driven down into the ground. Usually it's at least 6 feet that is being driven into the ground. Once it gets down that far, it will actually ground the appliance to the earth. And the ground terminal is being physically tied to the chassis. And in turn, that ground wire with the power cord that is finally connected to the earth via the 4-prong outlet. Okay. So it also, if I'm using 120 volts, there is also an earth ground in that, and that is the little center on the plug itself. Okay, so what does that actually look like? Here is an earth ground off of a telephone pole. Okay, you can see where it's driven. I've got a little mark there where it's driven down into the ground. That is actually driven all the way down. That is 6 feet long. It's driven down into the ground. This one, it could actually be 8 feet. I do have an 8-foot earth ground. That is a copper earth ground. It is solid copper. It weighs about 20 pounds. And it is taken, you take you take a hammer and you just drive that down into the ground until I'm ready to put connect it to the earth, to the appliance. That is done with a large copper wire. On top of that, there is a copper or brass, either one of those two, that ties the ground wire to the earth ground, and you tighten that up, and that makes it. So here's a third prong that is a physical connection that to the earth ground. Okay, the wall sockets that I had in my home in Daytona Beach. My house was built in 1938. I did not have any of these plugs that you see. Mine were just the top two plugs that were a ground and a neutral. I'm sorry, a neutral and a power leg. Okay, so I did not have this physical third prong ground, but I have since driven an earth ground in to the appliance, taken and changed it like it needs to be in the box itself, and tied the earth ground in to the box from all of the plugs, and gone back and replaced many of the plugs that I had. Okay, so here again, this is with an earth ground. You can see the earth ground, which is the wire that is highlighted right there. So that tells me that I have an earth ground. So let's talk about the dryer. So like I had said before, Whirlpool makes AMANA, Maytag, Whirlpool, several of the other ones, Roper, Kenmore. So there are several others out there that they actually also help make. So many of these dryers are exactly the same. There's little nuances, okay, that are different. But one of the things that generally is you can count on is that my control panel is on the top. My lint filter is right below that control panel. I pull that lint filter out. I can then clean that lint filter, put it back in. By the way, that lint filter needs to be cleaned every time you use the dryer. The reason that it says every time I use the dryer, because they figure that I'm actually going to do it maybe 1 out of 5 times so that I don't have the lint built up. As a technician, I have walked into a customer's home and I have found what I call a sweater on the control panel. That the lint is probably, it's everything to pull it out, and you're wondering what actually got down into it. So most of the time, if I get there and my lint screen is so thick like that, I usually tell the customer that I'm going to have to clean it. That does cost extra because my call is figured by how long it's going to take me. So I tell them there, I've got to clean this because you run the risk of having a fire. I have seen dryers that caught on fire because of all the lint that was in them. Okay, an electric dryer or a gas dryer, both of them. I have seen caught fire. Okay. So one of the other things that differentiates this from the other manufacturers, the door on the front is it's a square door. This is a reversible door. So if you look at this way, this is open from the left, and it opens. I pull it out, and it opens to the right. But if something happens, instead of my dryer not opening to the left, I can turn it over so that it can open to the right. One of the homes manufacturer that I used to work on much of their product, the dryer was always on the left side. Okay, so on those we had to flip the dryer door over. Okay, so that it would open, because you never want it so that for this dryer, I also have a washer that I'm going to have. So the washer has the lid on the top. So I'm gonna have to raise that lid, and I want it so that I can just stand right there and move from my washer and pitch my clothes into my dryer, and not have the door interrupting me being able to get my clothes into the dryer. Okay, the back of the dryer is basically the same. It has almost the same configuration across the whole brands. So that's just something I wanted to point out for you. Okay. What's wrong with this picture? Look at this picture right here. What's wrong with that? I will tell you that this dryer is about 15 years old. And actually, the answer is there's nothing wrong with it, because this particular where the earth ground screw goes to, that just tells me that how old it was. So it shows right there that 4-prong plug goes right there. I still have my L1, which is the black wire. I have my neutral wire, which is the center. And then I have my L2, which is the red wire. Okay. So this is with that cover removed. Now, one of the things that I want to sit and stress, okay, I have gone back and I've changed a little bit the flooring. If you know me, the one thing that I always insist on is protecting the customer's home. Okay. I always, whenever I had my own company, whenever I worked for a company that was not mine, but I had 20 technicians under me. Here's the requirements. Number one, I always have to have booties on. It is an OSHA law that you cannot remove your shoes. If you remove your shoes and you get hurt, it's on you. Okay. So I had myself, and then whenever I had technicians under me, we all have cell phones. Whenever I first started in this business, there was nothing, the cell phone had never been invented. I know I'm old. I'll turn 65 in about a week. So just give me a break. But we didn't have cell phones. The only thing we had was a two-way radio. But my cell phone gives me a camera. I used to carry a Kodak camera, not Kodak. Kodak camera that I took pictures with, because if I walked in and I saw that something was odd or not correct, I took pictures because I needed proof, because I have had too many customers come back and say, he damaged my floor. Today, there's no reason for you to ever not use your camera to check for damage. Okay. I've got a video that whenever I take pictures of that, I write it onto my ticket. I have the customer initial that. If the customer refuses to initial that, I tell them, thank you, have a nice day. You're going to have to call somebody else. I'm not going to get caught with that bill. I have, in other trainings, I have shown people places where I actually had technicians that said they didn't do it, and if they didn't have a picture taken, we had to eat it, because the simple fact was the customer said that they did it, but I've got no way to prove the customer wrong unless they take pictures. So always have your camera out and take pictures. After you do that, you always tell the customer, I need you to sign this, showing that there was previous damage. Don't take a customer's word. Oh, that's okay. Don't worry about it all. Don't worry about it. I had somebody try to pull that on me, and thank goodness I had actually, this is later on in my career, there was a cell phone. I did take a picture. It's the only thing that saved me, because the customer said, oh, he did it. He did it. He did it. And I had a picture of it. I showed my boss the picture. I sent it to my boss's phone or to his email. He took a picture of it. He went to the customer and said, I'm sorry, that's not correct. Here's a picture of the floor that was damaged. And here is where you signed the ticket saying that the floor was already damaged. Okay. We all need to be cognizant of customers. Okay. I just had a survey that I took, and that was one of the things that was on the survey was, how reliable do you think people are? You know, used to be that it was maybe one out of 20 that you had that was dishonest. But today, I mean, you think about all the cop shows and all of the TikTok stuff and the stuff on Facebook and all of that. Yeah, most of those people are lying, you know. I watched one with on a cop show, and the cop asked for the lady to get out of the vehicle. She said, I don't have to. Well, you do have to get out of a cop. If he asks you to step out of the vehicle, he will take you to the back, and he may issue a sobriety test. It may be something totally different. There was a reason that he wants you to come out of the vehicle, but you do have to comply to the officer's request. So think about it in that context about your customers. You know what? There are customers out there that would lie to your face and then think it was funny. That's just the world that we live in today. So always use flooring protection. Whenever I carried my toolbox in, I had a tool pouch. I took a mat, or I had a mat that I would use, and if I didn't use that, I had a towel that I would put down, depending on what kind of issues it was. If I was going to try to set it on a countertop, I used a towel. If I set it on the floor, I could use either a towel or a mat. Just, you got to be very careful, please, because it's you out there, and it's your reputation, and you need to be taking care of yourself. Okay, so always use flooring protection. Okay, there's always room for improvement. Okay, so 7 things to check whenever I'm working on any AMANA, like I said, or like Whirlpool manufacturer. Okay, if I need to check voltage, I'm going to check the voltage. I'm going to read at least 220 volts. Okay. So I'm going to go between L1 and L2. That will give me my 220 volts. If something happens and I have 110 volts, okay, I now know that I can go from L1 to neutral and check to see the voltage if I have 110 volts, or I can go to L2 and then neutral, and then I should still read my 200 and my 110 volts. That tells me that I may have a wire that is broken in the plug itself. It could be that my plug is bad. It could be that my wire coming that was furnished with the dryer is bad. That's the reason whenever you order a new refrigerator, if you order a new dryer, a new washer, they will not, unless you have brand new pieces, they won't install them in many of the installation companies. Okay, because they don't want to run the risk of them doing it, and then whenever they leave, something happens and it ruptures. Let's say it's a water line and it ruptures. It could leave you out there hanging. It could be that I have my dryer. Many of the dryers today have steam, so I have to have my special hookup for steam because I'm hooking it to the cold side of the washer to power my steam dryer. So I need to make sure that I've got all that, because once again, I'm trying to protect myself and my company. Okay. So if I go between L1 and L2, I get my 220 volts. Okay. My L1 would be the red wire. My L2 would be the black wire. So I'm gonna between those, and this one at my father's house actually is 247 volts. Is what his was. Okay. If I check between L1 in the neutral and L2 in the neutral, I'm going to read 120 volts, 123 volts. Usually it's 110. My dad has high. So that's going to tell me that I have the correct power coming from the wall to the dryer itself. If I don't have that, I can go to the box and look and see if the breaker's been tripped. Me as a technician, I'm probably going to go in and I'm going to shut the power to the dryer off. I'm going to flip it back on and do that a couple of times, and then see if I still get the same reading. But I need my 220 volts, unless this is a dryer that is 110 volt dryer, which would be a gas dryer. So if I have 110 volt, I still have that circuit that I have to make sure that I have voltage to, so that it will work. Because if I don't have the correct voltage, it's never going to light the flame. Okay, so after I do that, the next thing I'm going to check is I'm going to check the thermal fuse. Okay. A wiring diagram is a visual representation of the physical connections and the physical layout of the electrical circuit. Okay. It shows how the electrical wires and components are interconnected, and also show where the components are connected in the system. Okay. So I'm going to go and try to check my thermal fuse. Okay. We'll get back to that. So my gas dryer igniter should pull just over 3 ohms. Okay. So many of them today go somewhere around 3.25 to 3.5 ohms. Okay. Or amps. Okay. If I'm got it hooked up, I can use my amp meter, and I'm going to pull at least 3 ohms. 3 plus. So 3.15 up to 3.5 to 6. And that will tell me, if I've got my amp probe out, it will tell me that my amp, that the igniter should send power to the gas valve, which will in turn send the gas, it releases the gas. That in turn comes out. My igniter is now hot and has told the gas valve, I'm ready. Go ahead and release the gas. It sends the gas. The gas comes, it's hot enough, and it ignites. And that tells me that my dryer is working properly. Now, if I have a bad igniter, I'm going to look for the obvious to begin with. Okay. I'm going to look at if I get there and I have no glow on my glow plug, I'm going to disconnect it and I'm going to look for something. I'm going to look, if you look right there, I show you exactly where that is bad. So I've got to have one in my truck. I take it out. Once I remove that, I hook it back up. I make sure that I use the exact same wire nuts that come off of it. Some of the times today, they have a Mullinex plug on them. Okay. If my Mullinex plug has melted, I can go and find my ceramic wire nuts, and I can install it with 2 ceramic wire nuts. But once again, I have to be careful. I can't get anything on my hands that will transfer over to those wires, because they won't work properly. I have seen them. If I touch this glow plug, I had a technician that did it, said, there's nothing the matter with it, la-di-da-di-da. What had happened was he had actually touched that glow plug. The oils from your hands get on this glow plug, and it will cause the glow plug itself to short. That's what happened right here. Okay. So once again, I'm going to check this amperage jaw. It should be at least 3.1 ohms. Okay. Then if I'm going to check anything else, I am going to unplug the unit unless I know that I have already gotten everything out and that I'm ready to check my voltage. I can do that, but I'm always going to unplug this unit while I get everything ready. I do not want to hit this thing and me have 220 volts come across my arms, because that makes for a very bad day. It's bad enough if I am going between the washer and the dryer, and my my heating element has shorted to ground, and I go and I put my hands on the washer and my hand on the dryer as I'm going between them, I can get a shock. That is not a good thing. Thank goodness my feet are off the ground, because if I have my feet on the ground and I am in water, 110 won't let you go. So you have to be very careful. Okay. So the first thing that we had talked about was the thermal fuse. So here's the 2 configurations of thermal fuses. It depends on how old the unit is, which one of these you're going to get. Excuse me. The one for my dad's dryer is the one that's on the left. I came in and I changed out the operating thermostat, the high limit thermostat, and the thermal fuse. Okay. But here are the 2 configurations. So I'm going to check this. I've got to own this out. So once again, I've already unplugged my unit. So I am going to unplug both of the ends of the thermal fuse. I'm going to go between that. I'm going to see how many ohms I pull. I know if it's good or bad. Okay. The number 1 reason for this thermal fuse to trip is lint buildup. Okay. It causes the unit to run hot and it will actually blow this thermal fuse. Okay, so for me to check it, I'm going to set the meter to the tone scale. I have this one set right here for my meter, and it's set to the tone scale. The reason I like the tone scale is I can look at my meter. I don't have to sit there and look at my meter to see how many ohms I'm pulling. I can actually look at it. I don't have to look at it, so I can make sure that I have both leads to my meter are making good contact. So there's nothing worse than thinking that you have a bad meter, a bad component, and then you go to the truck, you replace it, and come to find out all you had was a bad contact. Okay, so to check my continuity through the thermostat, once again, I do the same thing. I can either pull off both sides, or I can only unplug one side. You can do it either way. I like unplugging both. That way I don't get a false reading. Okay. If you receive a tone, that tells me that fuse is good. So one of the other things, I can place the lead on the terminal and then the other lead on the other terminal, and I can check to make sure that my operating thermostat is working properly. This one actually hooks into the heater. So if I'm going to check my heater, I've got to pull off those two components, and I can ohm my heater out. That will tell me if my heater is good. If I am checking it, I'm also going to go though from one of the connectors to the ground on the box itself, where that encases the heating element. I'm going to check that just to make sure that I don't have the unit shorted to ground. Okay. If you receive a tone, the fuse is good. Like I said, I double check because I go from one side of the wire to the ground and then the other side to the ground, just to make sure that I have both of those and they're not grounded out. Okay. If I need to replace the fuses, I can tell you that as a technician, I have found that if I'm going to do this, I'm going to replace all the fuses. I'm not going to just replace one fuse. I'm going to replace them all at one time. There are kits that are designed. Encompass sells these kits. You can just go to Encompass, type in your model number, and then scroll down, and there will be kits down there. They have kits for the fuses. It has a kit for the rollers. Then they have one kit that includes the rollers, the belt, the idler pulley. That's another kit that they have. It's gotten so today that you can buy it in kits. And I always say, if I'm going to replace it, I'm not coming back in 30 days. I want the customer to be happy. I'd rather the customer say, well, that seems a little high. Well, yes, ma'am, but you have to look at what you're getting for the amount of money that you're spending. If I replace one, all of these fuses have been operating under the exact same conditions for a long period of time usually. And if one goes, it just tells me that I'm probably going to lose my other fuses pretty soon on whenever on the next time. And I don't want to have to do this. I don't want to have to go and replace one, show up in a month, and replace the other. I don't know about you guys. We had my policy was if you go there and I charge you the trip charge, the labor charge, the part charge, and I get a call back in 30 days or less, I don't charge you the trip charge. Okay, that's just the way that my company was. Many of the other companies that I have worked for, that was their same policy. So the last thing I want to do is to replace this and then have to go back and talk to the customer again. Okay, so whenever I'm getting ready to put this all back together, I'm going to use I don't like using a drill whenever I'm doing fuses. I like to use my nut driver or my screwdriver. This one actually is a socket that was put on because I keep both sockets and my nut drivers. So you just be very careful with this. So I'm going to secure the thermostat with the 2 screws. You can see right there where the one screw is. The other screw is down below on the bottom right side. You can see where it's already been put in. So do you have to be careful on my dad's on his thermal fuse? I'll show you a picture of it. He had the old thermal. Okay, so when replacing the high limit thermostat, there may be an additional wire that connects to the fuse element. So you got to know whenever I'm changing all this out, I want to change everything. I want to make sure that the wire is good and tight. Whenever I go to put the wires back on, I want them to fit snugly, and I have to actually push them on and pull them off, and it's good. Some of the wires that you're going to find on some of the Whirlpools, they had a little tab that you had to press, you had to pick out so that you could remove it. They did that for a little while. They went back and changed it because everybody cutting the wires and resplicing, and that's something you really don't want to do. Okay, so install the new thermal fuse by securing it with a screw, as you see below. Okay, the problem with my dad's is this is what he had, but his did not have. If you look right there, it's not another screw. It slides in and you push it up and it locks it into place, and then you put this bottom screw in. So you have to make sure that I take pictures if I think I'm not going to be able to remember how it goes in. Once I do that, I can then reconnect all the wires. I can turn it on, check it. I set my meter to the highest ohm scale. Okay. It should read between 30 and 100 ohms if it's good. The next thing is to check the push to start switch. We're talking about things that go wrong with this dryer. Okay. The push to start switch, I learned a huge thing with a guy, because the way that I was taught, I held the switch in. I had little alligator clips that hooked my meter leads in, and I could hook my alligator clips in there, and I would see if the push to start switch was working properly. Well, the problem is I don't always know that, because I have to hold one hand and I'm trying to look at my meter and see what it says, and I can't really see what the meter is telling me. I have to do it. So a technician showed this to me. I'm passing it on to you, okay? Because you always have to press that push to start switch to see if it's working. So what I can do is I can take tape. This technician actually had a roll of clear cellophane tape. He would tape that down. Now I would go back behind it, unplug the push to start switch. Okay. I'm going to remove it. I'm going to plug with the 2 wires attached, and then set the meter to continuity. We check between the 2 leads on the switch, looking for a tone. If no tone, with the switch depressed, I got a bad switch. If the unit has 4 wires, I've got to look at the wiring diagram to see what my correct lead placement is, because it could be that my 2 blue wires are not actually blue. Usually they're blue whenever I'm working on an AMANA. The problem is I used to work for Samsung, and one of the things that used to drive me crazy was they had like purple wire, and it was through the whole dryer. So you had no idea. You had to physically get a meter and a wiring diagram to even be able to trace things out. So you have to be super careful. I'm just telling you, make sure that I know what I am doing and that I'm putting my meter leads on the right points, because if I change it out and it's not that, I've just spent 20 minutes going to the truck, getting the part, coming back in, putting it in, plugging it all back up, pushing the button, and lo and behold, that didn't fix it. And now I've got the customer looking at me going, what, do you really know what you're doing? Okay. So you're just going to have to check the diagram and make sure that I have the correct lead placement. Okay. So now we're going to check the door switch. Okay. The door switch is in the top right corner. If I have if I open the door from the left to the right, if I'm opening it from the right to the left, on many of the dryers, I can swap that switch out and put it on the other side. Okay, so I'm going to check the door switch, because the dryer will not even start if the door switch is bad. How am I going to do that? Well, I'm going to have to I can either go to the wiring schematic, find out where the wires are, where they go into the timer, or if they go into the push to start switch. I'm going to find them there, and I'm going to trace them back. I'm going to check and see if my door switch is good. If my door switch is bad, I'm going to have to disassemble everything and come back to it. Okay, so if I hear a humming, one of the other things, okay, let's just take this, not a simple. Let's say I have to replace the door switch. For me to replace the door switch on an AMANA, I'm going to have to pop the top up. After I do that, I have to take out 2 screws. You see them right there. If you look on the very bottom, there's also 2 screws that are down there. Those are the wrong screws. You take the ones off at the very top. So I can now lift the lid. Once I lift the lid, depending on what I'm looking for, I can take the screws out and lean the panel forward, and I can get to the lid switch. That I can usually mash it and know that it's either good or bad. Sometimes you can't. You have to take your meter and use your meter to check the leads to make sure that that's good. So that's another thing that you really need to be able to do. Okay. Let's say that I think that whenever I have the push to start switch and I hear a high pitched hum. Okay. Well, I'm going to lift that lid. I'm going to look and see if I can stick my finger up under this belt. If I can stick my finger up under the belt, I have one of 2 problems. I either have a bad belt, or my belt has come off the pulley. So I've got to go and figure out which one those are. Okay. So The next thing, okay, I'm going to check the timer. So I'm going to check the power to the timer. And since we verified the push to start switch is good, when you press the push to start switch, listen to see if you hear the motor windings try to start. If not, check the power to the motor. If you have power, you have a bad motor. And then check with the customer because of the expense of the motor to replace. But if I want to check the timer to see if my timer has shorted, and I will tell you that it's very easily, this is probably the next thing I'm going to have to replace on my parents' dryer is this timer, because I'm going to have to check for the timer to see if it's shorted. So I'm going to set my leads on my meter. Okay. Then I'm going to take and go between the red and the black Molenex plug. You can see it right there where they are. If you look down at the wiring where it's plugged in for the Molenex, that shows my red wire is the first one. Then I have a blue wire, and then I have a black wire, and I'm going between that red and black wire. That will tell me if my motor actually works. If one of the things that I will tell you, the first thing I'm going to do is probably go ahead with it plugged up. I'm going to try to turn it on and see what happens. If it starts to work, I take and wiggle that switch to see if it breaks contact. If it breaks contact, I probably have a bad motor itself for my timer. My timer motor itself the connector may be bad. So I'm going to have to replace the timer. Okay. But I need to do this. Okay. See, I'm going to wiggle the knob to see if I break the contact. I go through that and do each cycle. My dad's works great in the time right there. On the auto dry, it doesn't work so well because that was the cycle that they always used. So it could be that that's bad. So I can go and I start it. If it starts, I'm going to wiggle it a little bit. That works. If it breaks contact, I know I got a timer that I'm going to have to replace. If you have one come into the shop, like I used to work for Best Buy, that's one of the things that we always did, was because we had like 8 or 9 that we'd line up and check at a time. So that was just one of the checks that we did for that, just to make sure that we didn't have a timer that we had to replace. Okay, if I'm going to check the motor, okay, this is one of the, how am I going to confirm that the motor is bad? Okay, one of the things that I did not mention, okay, if I come in and I push the push to start switch, okay, and it starts turning, I can still hear my motor. And if I hear that I have this banging or clanging or something like that, I may have to go and pull the back of the unit out. I'm going to have to then look at the fan itself, because this fan, if I had a child that had somehow shoved a little block into the down where you put the filter, got that, he pushed it all the way in, got that filter, and whenever it stuck, it actually broke the fan. Well, if I'm going to have to replace the fan, I may have to replace the motor. And if I have to replace the fan and the motor, I probably have just about the cost of a new dryer in by the time I figure my labor in. Okay. So you need to be checking everything that you can think of to make sure that I'm right. Okay. So, but if I get to it and I'm going to confirm that the motor is bad, everything else is working, I am going to, well, here it is. I can inspect the dryer blower wheel for any obstruction, make sure that it's free. It's not freewheeling on the motor itself. I have found those freewheeling. I also have had to go and get my vacuum and suck all the lint because the customer wasn't cleaning the lint filter, and it all gets down into this motor, and that causes it not to circulate the air, and that usually has resulted in a complaint about it not drying properly. So one of the other things that I will tell you before we get to the motor checking, the first thing that I always try to tell people is I have to know how long my vent run is. I have to know how many ups and downs there are into this, how many elbows that I have. I walked into one that was a 30-foot run. It went straight from the dryer down through the floor into the basement, went all the way out to the outside. But every time it went, it heated. It was not a continuous solid pipe. It was flexible ducting, and whenever they had put the flexible ducting in, it gave it hills and valleys, and that was the reason that my unit did not dry properly. The customer said I didn't know what I was talking about, so I unhooked it, told them don't go in the basement whenever you're because this is back during the winter. Just don't go in the basement because it's going to be very humid, because that's what your problem is. They had actually taken the 4-inch piece of pipe and had it go through the floor and then put flexible ducting on that, and it was that really super cheap flexible ducting, looked like tin foil, and that's one of the worst things you can have. But they called me back and they said, okay, you're right, we need to have it fixed. So they had to call somebody else because we did not run ducking. That would have been a pretty easy job for me to do, run that ducting. I've got my parents' house here, and one of my dad's complaints was it's not drying properly. I got up under the floor, looked, and he's got the same problem. So that's why it's not operating properly. So just make sure that you check everything out before you go and tell the customer, oh, this is the problem. Just make sure you do all the checks whenever you're going. Okay. So before I get any farther into this, I'm going to stop right here for just a minute. I'm going to ask, do you guys have any questions over what we've gone over? I see we have 5 people in the class. Does anybody have any questions? I want to address your questions if I can now, because when we get to the end, I'm going to ask you to watch almost a 2-minute video that shows Encompass, and I want you to know. I want to know if you have any questions now. So could you please let me know if you have any questions? And I'm going to take that opportunity to get a drink of water. Okay, we're going to go ahead and we're going to continue on. Okay. Once I get to the motor and I'm going to check all of this, there's 2 styles. One has a Molex plug and the other one has all these wires. If I am going to go and try to work on this, I am going to take a picture of the one on the left so that I am sure that I have every wire in the right place. There's nothing that takes more time, unnecessary time, than not taking the picture, looking at it, and trying to work off of that. I will tell you that I just replaced batteries in my father's golf cart, because that's what he rides around in. If I hadn't had that, I would have had issues with trying to make sure that I had all of the components plugged into the right port, the right clip, because it was just like this dryer. There was a total of 8 wires that came down. Okay. In the old days, I used to take my ticket that we gave the customer. I would turn it over and I would draw on it, just so that I knew which wires, red, green, blue. I would write that and write the wire color associated. I would write whatever the wire was there. If you look at that one, if you look at that that unit, you can actually look, and one is RD, one's GY, one's BU, one is TL. And if I have something and it doesn't have a wire put on it, I mark that down anyway, because there's nothing worse than getting there and you got an empty wire and you got one thing to put it back on, and you're not sure if you've got it right or not. In the old days, if you look, there's 2 screws. In the old days, you could change these out, and you could replace just that switch, the motor switch. Okay. Or there was a thermal that you could replace. We're gonna talk about that in just a little bit. Okay. So if I have to disconnect those motor wires, I'm going to take a picture first. Okay. If I have the Molenex plug, I'm going to remove that Molenex plug, and then I'm able to work on the unit and verify that I have a bad motor. Okay. So once again, I am going to use my wiring schematic, my wiring diagram, whatever you want to call it, to determine where the motors start and run windings are located. They're on the motor somewhere, but I still need to know where the contacts are. Okay. So this one right here is, you can see that M5 is one end of the run. Okay. Then I have an overload protector. That's what I was talking about. This overload protector, you can actually replace that also if I had to. So I'm going to use my schematic. I'm going to go through there. Then I'm going to isolate the start and the run wires by detaching those 2 wires. Once I do that, I'm now going to take and use the lowest ohm setting. This one is actually the tone, because that's what I always use, is the tone. Now use the black connector lead and touch it to the motor connector terminal. Okay. Once I do that, then I take the red lead and touch the start winding terminal. Okay. If the meter shows 2 to 5 ohms of resistance, then the start windings are good. Now I move to the run windings, and I repeat the exact same thing. Okay. And if it shows between 2 and 5 ohms of resistance, then the run windings are good. Okay. So that's 0.4. So that's a good lead. If they both show 2.2 to 5 ohms of resistance, then the motor should be functioning properly. The only thing that could be wrong is that could have been my thermal protector. I'm showing you a picture of that thermal protector right there. And that ensures that the voltage going to the motor is correct. So what I can do to check that is I can disconnect the terminals from the connector. Okay. And I'm gonna ohm that out. If I go there and I ohm that out between those two terminals, it should be, of course, with the ohm on the lowest ohm setting, I should get very close to 0 ohms. If the terminal connector has no continuity, the motor will have to be replaced. This all gets back to now is the time that I'm going to need to have a conversation with the customer. Okay. I am going to go and say, Mrs. Jones, here is the price of the motor. Here is my labor. Here is my trip charge. Here is what it's going to cost you total to fix this. And I just want to get you to sign off that you want to replace the motor, because there's nothing worse than ordering the part, getting it in, and the customer go, I didn't want that. Because now I can't send it back because I've just installed it and put it in so the parts house knows that I've done it. And they have people at Encompass that's what they do is they go back behind it. And if they find out that you have actually tried to change and didn't let them know that, then they have the ability to charge your account back and say, hey, you tried to give us a bum part. So if the thermal connector, I always make sure that if I'm going to have to replace the motor, I am going to have that conversation with the customer. I'm going to have the customer initial that they want the part replaced, and I am going to order it unless I have one on my truck. Whenever I was a technician, we were a Whirlpool Tech Care service. Most of the motors were about the same, so I used to keep one in my truck. So that's probably something that you would want to do. Okay, the last thing is, does anybody have any questions? I want to thank everyone for their time. I'm going to ask you that you just hang on and spend 2 more minutes watching the video. There's not another class that is an in-house class, except for one in Texas and one in Lawrenceville. One is for R600, and then the other one is for PTAX. So if you're wondering if there's anything out there, go to the website, Encompass Training. You can go to it and look at it, and it will show you all the classes that are coming up. Okay. If you have any questions, please let me know. My name and my number and my email address are all scrolling across the bottom of the screen here. If you're going to call me, I just ask that you text me first and let me know, because I have so many calls with me turning 65. All I'm getting about 6 times a day is somebody trying to sell me insurance. So just please hang on and watch this video. Like I said, this one is 1 minute and 50 seconds, so it's almost 2 minutes. But thank you very much. Have a wonderful day. Thank you, and we'll see you on Thursday.